Testing. Testing 1, 2, 3. Testing. Testing 1, 2, 3. Okay, so for this module, you will have a backup of video recording every session of the lecture. Yeah. So we have gone through all the fundamentals understanding. We have gone through the LO yesterday class. So pay attention that we will focus on particles and rigid body in this module. Your test 1 will cover all the equation related to particles. Your test 2 will be a mixture of particles and rigid body. Your final will cover these 4 LO, right? So your final exam have 5 questions, 3 compulsory, 2 option. You can choose either answer question 4 or question 5. So here, roughly you can know each one of it will come out 1 question, 1 question, and 1 question, and 1 question. All right. Okay. Let's go into chapter 1. Chapter 1, today we will look into rectilinear motion, which is linear motion. Linear motion. If we have time, then we go into curvilinear motion. It depends on how deep you can absorb. First, we start with a few definitions. What is mechanics? Mechanics is deal with motion. Motion can be rest or can be moving. Motion, it can be rest or something that is moving. So engineering dynamics or engineering mechanics, we can divide into static and dynamic. Statics is what we have covered, and make sure you already passed the static module. All right. Now, yesterday, we mentioned in static, all the force equals 0, all the moment equals 0, and free body diagram with the force and moment. So static, you focus on equilibrium, and the velocity is constant. All right, you'll find out that if you recall back what you experienced in statics, most of the value is constant was given to you, and you only need to apply the specific equation, then you can solve already. However, our module here will be solving for equilibrium, meaning force is not equal 0, the moment is not equal 0. You need to find the sum of the force to balance the system. All right, and we deal with this one is dynamic already. So dynamic, we deal with accelerated motion, meaning we will expand what you learn, velocity into acceleration. As you learn in physics, what is acceleration? Acceleration is a change of velocity divided by change of time. This module, we deal with change of time. Yeah. So in static, maybe you're not so much dealing with time, but in dynamic, we look at the time dimension. Okay, so these are our general ideas. So in dynamics, there are 2 expectations from you. First, you need to know what is kinematics. This one deal with geometric aspect. What I mean by geometric? Meaning when you solve for question, especially you draw free body diagram. Yesterday we mentioned how the question come from. Question A will ask you to define something or free body diagram. In static, you need to draw free body diagram. This is free body diagram in kinematics with coordinate system, X and Y. So this one is deal with this module. When it comes to engineering dynamics, first you deal with kinematics diagram, which is deal with the geometrics. You need to give the location of that object. Okay, first one, the first diagram. Second diagram, we deal with kinetic diagram, which is the motion of that object. This is more on motion, or we call it kinetic diagram. One is kinematic diagram, one is kinetic diagram. Or for the rest of the lecture, the one that you learn in your statics, I will use free body diagram. Free body diagram means you deal with force and moment only. However, later you will see you need to draw one more diagram. It's called kinetic diagram that deal with motion. Normally only deal with velocity and acceleration. So you need to include this one in your answer. Okay. So for dynamics, you need to deal with kinematics and kinetics. All right. Okay. Now these are the steps that you have been trained well. I will just go through all these. So all this you can read. First, you read the question. Normally, again, I will trick you with unit. Read the unit carefully. Normally, I will put, for example, yesterday I mentioned mass. Unit SI is kilogram. However, in tests or exam, you might see megagram. Remember to change this one into kilogram. Yeah. So read carefully, and then second one, go and analyze the question whether this one comes from which chapter. Each chapter have their own specific equation to use. All right. So first read and then try to think, oh, what this question related to which chapter. Then after that, you solve. You come up with a diagram. Diagram, this one I mentioned already just now. You have two diagrams to draw. Maybe test one, you only need to draw free body diagram or kinematic diagram. However, when it comes to test 2 and your final exam, normally you need to do two diagrams. Okay, and sometimes once you do enough practice in your exercise, sometimes we combine these two into one diagram. Okay, later we'll come into that detail. Then number 3, you do calculation. Number 4, you make judgment. Right, you make judgment. What is the value that you see? Normally, this is B section. You calculate. C section, you answer the question why. Why or how? Usually deal with the motion. What makes the things, will it continue to rotate or will it stop at a certain time? Okay, yeah. So that is the general steps. First, we go into chapter 1, the first things, first diagram. We imagine that one particle moving in the straight line. If the motion is straight line, it fall under rectilinear motion. And now we deal with continuous motion. Yeah, we have a different kind of motion later. Continuous means it continue to move in the straight line. Later you'll see it move, then stop, then move again and stop. This is continuous motion. So first, you need to know the location. So you draw on a straight line, draw particles, label in our module, starting point, I will use 0 or O as a initial location. So this particle move in a straight line, it fall under rectilinear motion. So kinematics of rectilinear particles, you need to focus on these three things: position, velocity, and acceleration. We'll start to with your three important equation for chapter 1, position, velocity, acceleration. Right. We start with position, yeah? So position is where is the position from referring to your reference point. In this case, this yellow particles was a certain distance from the starting point O here, labeled as S. This is called position. Yeah. So throughout this module, we will use S as position. So in your answer for your test 1, test 2, and final exam, don't use other alphabet unless you define it in your answer. Let's say you don't want to use S. You want to use other, I don't know, maybe you H or Q or P. Make sure you write what is position or what is that alphabet that you use. Huh? If not, I will put a question mark. Oh, this is not in my slides. I do not understand what you're writing. Huh? Again, we start with deal with vector. Position is a vector quantity. Remind yourself that vector have magnitude and position, or direction, sorry. Magnitude and direction. You have magnitude and direction once you have a vector, right? So position is a vector. So magnitude is you use ruler to measure. Direction is either to the left, to the right, or a certain angle. Then we start to deal with, we have a position already. Now there's a redefinition of what you learned in your physics. Some of us, we like to use displacement for position, but when you come to engineering dynamics, be careful. If you see the answer asks you to see displacement, it asks you to find a certain things. So displacement is change of position, it is delta S. So as you look at the diagram, so it moved from original direction position here S, move the new direction, we will use S prime. So for this module, if you don't see anything, it means original parameter. If you see something like S prime, it means first changes of position. In this case, second position S prime. Mathematics, to calculate displacement is delta S. Right, sorry. Delta S equal to S prime minus S. Means you take the final position minus the original position. Again, you deal with vector. Right? So vector, in your mathematics, you deal with vector and scalar. Magnitude is scalar, means it's only a number. But if you deal with vector, means you have a magnitude and direction. In chapter 1, you deal with straight line motion, which is only one direction. Okay, first equation for today, delta S equal S prime minus S. So this is another highlight. Again, you are dealing with vector. How do you use what you learn, the displacement, to define velocity? So in your free body diagram here, all the motion to the right will be positive. All the motion to the right will be positive. So in your free body diagram, it's important to write where is positive, where is negative. Yeah. Okay. So if you go up positive, then you make a note in your diagram, positive, where is the direction? We will deal with two definitions of velocity. First is called average velocity, happen during the delta t interval. If you mention average velocity, you take the delta s divided by delta t which means that it's still a vector form, because your displacement is a vector. So you take delta S, which is in green color on the slide here, delta S divided by the time to change the displacement. Another velocity, we call it instantaneous velocity. What I mean by instantaneous is like watching a movie and you press the pause button. So what is the velocity at that particular time that you are looking at? It's called instantaneous velocity. So you know that in your mathematics, in your calculus, you transform something delta to something that you can measure. Delta means very, very small changes, but you want to change that very, very small changes to a well-defined parameter. You need to go through one process called limitation. You need to use the limitation. Delta t to 0 means you pause the particle at that particular time. You freeze the time dimension. That's why there's a delta t to 0. Okay. Again, this one is your mathematics chapter. I will not go deep into that. What is important is that how you use the average velocity change into instantaneous. There's a process. Then you'll get ds dt. So instantaneous velocity, you use v equal to ds dt. The d means the one that you can measure. If you see d means you can measure. Okay, things that you can quantify. So we have two definitions. One is average velocity, one is instantaneous velocity. So be careful in your answer during the assessment. So don't simply use delta and don't simply use d. So velocity will define. So s already give you the displacement, give you v already give you. So velocity s just now s delta s equal s prime minus s. Velocity, instantaneous velocity, v equal to d s dt. We have one more, acceleration. In your physics, you know acceleration is a time differential of velocity, right? So it's just a note, Okay. So if you get a positive value of v, it means it moves according to your assumption. Our assumption for chapter 1, rectilinear kinematics, to the right is positive. So if you get a positive v, it means to the right. Just a note here. Positive is moving to the right. We move on by using the definition of displacement, definition of instantaneous velocity. We derive equation for acceleration. There's something, there's one, okay, before I move to acceleration, there's two more slides. Average velocity just now, and then one more definition or one more term that you use frequently in your physics when it comes to engine dynamics. Average speed. Speed is a scalar. Speed is a scalar, so be careful using velocity and speed in this module. All right. So how do you find average speed? Average speed, you take total distance traveled divided by the time needed for the incident to happen. Okay. So average speed is st divided by delta t. Speed is a scalar. Velocity is a vector. Okay. Then if you look at your tutorial question, you'll see a diagram there. In question number 10, there's a diagram there. Just now, these two equations we mentioned before, average velocity equal to change of displacement divided by time. However, when it comes to speed, you take the total distance traveled divided by time. You're given this diagram. Let's say you have an initial position here, moving in a straight line. We call rectilinear motion, straight line. And let's say the initial position at P and these particles move back to position P prime. Again, for this module, you'll see prime means there is a change of something. In this P without the prime means original position. P prime means something happened compared to the initial element. So this P move from here to here. So is there any difference between velocity and speed if you do calculation based on this diagram? Yes, sir. What is different? Direction happen. If this one move forward, not the both will be the same. But if particle move a bit from what all the movement to the right is positive, then one of it will make changes, right? So average speed here, you take the total distance means you take here, it moves somewhere back here, or this one here, right? It moves from here. So ds dt, dt divided by delta t. However, average velocity, you get a negative sign there. Why? Because displacement is always referred to the origin to the end location. So this is the original, this is the end. It moved backward means negative delta s. Right? You take this one minus this one, right? Sorry, you get this one minus this one. So a bit shorter. So you get negative sign there. So there's a different, if the question asks you to find speed, if the question asks you velocity, there's a different answer. Okay, take note on that. Don't simply use speed in your answer and also velocity. Okay. Okay. Next, we move on to acceleration. Something changed to the diagram. In this case, the particle moves again along the straight line. However, here, we will look at velocity rather than displacement. So let's say these particles initially start with initial velocity v, move to the right, which give you positive value, and move to the second position, give you v prime, also move to the right, which is positive. How you calculate velocity acceleration? In this case, I'll use the extra arrow. I denote as a. Right. So again, in this module, you have two types of diagram. One is kinematic diagram, one is kinetic diagram. The one you see, the blue line is kinematic diagram. The one you see with the acceleration velocity is called kinetic diagram. Yeah. So again, average velocity acceleration, we take your velocity, change of velocity divided by time, you get average velocity. You apply the same to find the instantaneous acceleration by using the limit time delta t equal to 0, means you freeze the time and look at that particular time, you will get acceleration equal to dv dt. So the third equation for today, dv dt. Can you derive equation acceleration? This one is in terms of velocity. Can you derive acceleration equation or differential equation in terms of position? The answer is yes. What is the definition of v? It's this one. What do? You differentiate this one 2 times. Right? dv equal to ds dt dt. This is your differential equation. So you get d squared s dt squared. It means you differentiate this equation 2 times. You take the s equation, you differentiate 1 time, 2 times, you get acceleration. Okay. Now, how to apply this one? Again, in this engine dynamics, you will not get constant value anymore. You'll get equation s equal to 2t plus 3, maybe square. So means that this s move in term of time, 2t squared plus 3. So you want to find velocity, you need to apply the differential equation. What is v from this equation? You differentiate s towards t, like what you do dy ds. So this one become 4t plus 0. This is your velocity in meter second. Make sense? Sense? Now, if you want to use velocity, you want to find acceleration. You want to find acceleration. What you do? dv dt means you use the v equation to find acceleration. dv dt means you take this equation, you differentiate towards time. What do you get? What do you get? 4 means 4 meter per second square. Let's check the second approach. This is first approach. This is second approach, where you'll see this one most of the time in your final exam. How to find this one? So let's prove this equation. So A, you can do double differentiation, meaning you do this one, ds dt, you get 40, right? You take this one, you get 40, and then you do one more time, ds square, dt square, you take this one, you still get 4 meter square. Make sense? So there are two approaches. Sometimes the question do not give you v, they give you s. This is the another door for you to solve. Okay, so this is called dynamics. Static, you won't see this one. When it comes to dynamics, you no longer see a constant value. All right. Any question for 3 definition for position, velocity, and acceleration? Good? Everyone good? Am I going too fast? Something wrong on my side here. Acceleration doesn't deal with either move to the right is positive or right negative. This statement is wrong on my slides. Take note. What mean by you have A equal to 10 meter per second and you have A equal to negative 10 meter per second square? Which one? Which one? Yes. Yes, tab 1. Where you point? Yes, tab 1. This is V, right? Okay, this one is, okay, this one, mathematics. dv dt, you can write as d dt v, right? What is v? Means same. Here I just put, or you can write this one. This one I write a bit fast. Make sense? Yeah. Okay. So I derived the equation for you already. Here, sometimes the question a bit tricky. It will tell you velocity is constant. When the velocity is constant, your acceleration straight away equals 0. Yeah? Anyone who cannot understand why velocity constant, acceleration 0? constant. Means time t1 10 meter per second, t2 also 10 meter per second. Is there a change of acceleration? No, becomes 0. Straight away your a equals 0. Then you substitute a equals 0 in your equation. Right? Okay. Do you guys need break? Huh? Yes, Okay, we take a short break. How long you need? 10 minutes? 10 minutes? Okay, 10:45 we continue. Okay, 10:45.